Hello, everybody. Let me record this video to memorize Professor Pete Lu, retired professor from Department of Electrical Engineering of UConn stores. We have three papers to share with you. The first one was presented at ISA Power Industry Division's International Symposium in 2007. Vinaya did the presentation. He was a graduate student at UConn, and Professor Lu was his advisor. At that time, he worked as intern or co-op at Awesome Power with me, Joe, and Carl. So that's me. So at that time, my title was consulting R&D engineer on controls. So, and this paper focuses on developing linear model-based controls using gas-fired boiler simulator in Appros. I can show you the figure. So this is how we generate data using a simulator, and with the data, we develop the linear dynamic model. This is how we do the transfer function model, and this is NPC design, and then we developed the NPC program in MATLAB and Simulink, and I did this work as a graduate student at Carpenter Engineer at Allston. And then from MATLAB platform with the NPC controller in it, it communicates with the simulator, a virtual plant, to simulate a gas-fired boiler. So this Appros 5, version 5. That's the old version. So it has this interface. Now we use Appros 6, which has a better graphic user interface. So in this one, this is the first trial, and we developed this, and we compared the performance between NPC and PID, and we show the improvement. So if you can check for this paper. So this paper is was presented on the 17th annual Joint ISA Power Pre-Controls and Instrumentation Conference, and also it is listed as the 50th annual ISA Power Symposium. So it's one conference with two titles. So, and it was hosted in Pittsburgh, Pennsylvania. So, and this is the first paper we did between Austin Power and the Electrical Computer Engineering Department of UConn. So, Vinaya was listed as the presenting professor, and he was actually sent over there to present this. I was there as the symposium participant. So and then the next year, 08, we extend this work as the linear model-based work, model-based the NPC work was really good, and the managers, Carl is pretty satisfied with that. So we discussed with Professor Pete Lu and how we can extend that from a linear model-based controller to a nonlinear model-based controller, and see instead of using a first principle model, we use neural network model. Is data-driven model, what we call machine learning today. Well, we use the same Appro simulator, a gas-fired simulator, to generate data, and we use the PIBS sequence. PIBS means we give the random perturbations. So to this simulator to excite the simulator by changing field flow, spread flow, feed water flow, and valve positions. So by saying spread flow, we kind of break the PI loop for sourcing temperature controls. So that's one way to do it. But the other way to do it is to keep the PID loop closed and use that set point as input. That's called supervisor control. But this one is to develop a direct control using NMPC. So this one is this is a dynamic neural network model, which because we use different time steps, so you carry the dynamics of the dynamic information of the process. And then it's measured what's the predict. This is really check the neural network model, the training data versus the predicted data. So we said measure is really simulated. So and then it's nonlinear NPC design. This is a quadratic, use a quadratic function and use the model as the constraint, also the controls and the rate of change of controls, and also output is a constraint. So this is a typical design of a quadratic optimization with constraint to model and input-output constraints. This is standard nonlinear NPC design using quadratic cost function. So, and then this one is constructed in MATLAB. As it looks similar to the linear NPC, but look at the model is the simulator is in Apros, and we is connected using OPC, and the nonlinear PC controller was developed using MATLAB. If you click this, you will get into the next level of simulation model, and embedded is MATLAB file, is M file. So with the model and the optimizer. So here is just a graph. So so it's the same structure, linear NPC testing or simulation testing bed. It's you have MATLAB, which has the nonlinear NPC controller in it in Simulink, and from Simulink we sample communications using OPC, standard OPC, with the April simulator. So this is the OPC client, and this is the OPC server, and this one running with this, so they can communicate back and forth. So and this is the simulation results, and we compare with nonlinear NPC versus the linear NPC, and here's we draw a conclusion. I mean, this is really exploratory study, so it's good. It's really the progress is removed from linear NPC design to nonlinear NPC design. Pretty early stage to claim nonlinear NPC can create a more profit than linear NPC, because we need to design the scenarios. Any advanced technology, if you want to create benefit, you need to find the right scenario. So so with this, we delivered the second conference paper to send message where we are. We have the neural network based nonlinear dynamic model, and based on the model, we have nonlinear PC, and we test that against the simulator. And we'll move forward to the next year. So we present this paper. Even I was still sent to this paper, and he's listed as part of us. So he started working for us. So. And Lu is still advising him as advisor, and this paper is it's used the same design, nonlinear PC design, and all it's the same model structure, same model pre-control development methods and test method. But in this paper is first on testing the sequence to excite the simulator to generate data, so that what kind of model should be developed that can best support the NPC, nonlinear NPC. So we use the PRBS and we generate, and we also introduce a sine wave, because we excite the sine wave with different frequencies. So and then we design the set. So look at this. We excite the system using different is a different a combination of PIBS signals and the sine wave. So and then as we get the simulation data, we use the data to fit the neural net model or machine learning model, and then we do some deep say the model. We evaluate how the model map between input output, some deep study, and we draw the 3D plot. It's a pretty good got pretty good insight if you want to read into this paper, and then this is the same. So as completeness of the paper, we still list the quadratic optimization design for non-NMPC, and we examine the different cases and try to draw conclusions. So what is the philosophy to design the exciting signals? So here we say exciting signal including PIBS, sine wave. We investigate visualization that sine wave exciting signals better input-output space capability. Both types of signals and their combinations were selected to test selected design test input generate test data for neural network model identification. All of these exciting signals in the context dynamic model were evaluated. Okay, so then we draw the conclusion. Yeah, the test method will be further evaluated in some field test work for both supercritical subcritical ball and plant for model analysis. So it means we're going to move from the simulation study to the field test. I mean, we can inject PIBS assigning where the small scale changes to excite the dynamic system. So we can, in the real plant system, it will not cause big interruption to the system, but can inspire, not excite the system to respond to the input signal, so disturbance signal. So NPC design will be further explored for next generation clean power system with a wide range operation. The best is smart grid system. Smart grid, I mean, it's a big picture. So smart grid and CO2, that's what US DOE asked for, or the power industry has been advocating. So this is a yeah. At that time, John Marin was the director of called Awesome Power Plant Labs, and Nancy Moon was the marketing director. So it means there is support from technology part and also support from marketing part, so product development part. So this is three papers was generated with corporate and the local universities. And Dr. Lu was best known as optimization professor in this field. His advisor, Professor Ho, is a world famous professor at Harvard. So yeah, this is to memorize Dr. Pete Lu, who passed away most recently. Is a good friend of mine and a professor I respect. Actually, he's a friend of my advisor at Cass Western Reserve. Is Dr. Ken LaPero's friend. So yeah, I feel it's really sad. It's a big loss uh, to lose Professor Lu, but by looking at the work and by recalling the sweet times we worked together on the important control things, yeah, I was really motivated to do better work in the future. Thank you for looking at this video, and if you have any feedback, please put in the comments. Thank you.